All right. I've got 7 p.m. Eastern on my watch, so I think we can go ahead and start. This is Prosody I, Part 2. My name is Rachel Steindl-Burdine, University of New Hampshire, and I'll be chairing the session. I'm sure most of you have been to a panel already, hopefully, but we have 20 minutes for talks and then 10 minutes for questions. You can either submit questions through the Q&A box, or you can raise your hand and I will call on you. I'd also like to encourage any graduate students or junior scholars to go ahead and jump in and ask questions when we get to that part. Sorry about that. Are people able to see the interpreter now? Hopefully. Excellent. Sorry about that. So we will go ahead and get started with our first talk by Aurora Martinez Del Rio and Diane K. Rentari from the University of Chicago. Repetition reduction across multiple repetitions in ASL fingerspelling.
All right. Hello. Let me just share my screen. Okay, hello. Today I will be talking about repetition reduction as it occurs across multiple repetitions in words in fingerspelled words in American Sign Language.
Just a second, the interpreter isn't visible.
Okay, thank you.
Blake, are you able to? Sorry about this.
That's okay. I can't see the chat, so please let me know.
Yeah. So we can see the interpreter now. All right. Sorry about that. And it looks like the interpreter is now pinned, so hopefully that will fix that.
All right, that sounds good. Are we all set?
Yes.
Perfect. Okay, so hello. Today I'll be discussing repetition as it occurs across multiple repetitions of fingerspelled words in American Sign Language. And in doing so, I will be more broadly addressing how this particular phenomena can give us insights into some of the factors that shape language production. Now, what do I mean when I say repetition-based reduction, at least in the context of this presentation? So previous research has shown that there is this relationship between the number of times a word has been mentioned and the duration of the word. In this relationship, as mention number increases, word duration decreases. And as an aside, I'm talking about word or fingerspelled word level reduction. So I'm not talking about any unit that's smaller or larger than this. So for example, reduction at the phrasal level. Here I have an example of repetition reduction as it occurs in fingerspelling from our data set. And fingerspelling, for those of you who aren't familiar with it, is a representation of English words through a set of hand shapes that occur sequentially, as well as a limited number of orientations and movements that map onto letters of the English alphabet. And it's fairly common in discourse in ASL, and it's used for things like brands, names, emphasis, and compounding. The example that I will show you here is 3 subsequent mentions of a signer fingerspelling the word diet. And I'll play them for you in sequence, and I'll play each of them 2 times. So here's the first one. So you can see, or you hopefully saw, both from the videos and the indication of length that I included here, that when she fingerspells the word diet, it gets much shorter by the 3rd iteration. And you probably also noticed considerable co-articulation and possible letter deletion. And so the focus of this current project will then be to look at how wide patterns in fingerspelled word length occur and how this length reduction proceeds across multiple mentions of fingerspelled words in ASL. And we'll additionally look at what other factors might influence this length reduction. So the primary question that this research is addressing is, most broadly, what is the relationship between a fingerspelled word's previous mentions in discourse and the length of the fingerspelled word? More specifically, we want to know how reduction in length continues past a word's second mention. So for example, does reduction continue ad nauseum with the same amount of reduction continuing each time a word is repeated, or is there a limit to how much words reduce? We also want to know if the time between repeated word mentions influences reduction in length. Additionally, previous research has shown that phrase final lexical signs are lengthened, they're longer, but this has not been tested for fingerspelled words. And so we'll additionally be testing if phrasal position rather influences the length of repeated mentions of fingerspelled words. So just as a roadmap for this presentation, I'll begin by discussing some of the previous work that's been done on repetition reduction as it occurs in both fingerspelling in American Sign Language and in general speech research. And I will also provide the theoretical backdrop that has been proposed to explain these findings. I'll then outline the research predictions for the current talk and the methodology and corpus that we used to test these. I'll then go through the results and their implications. Now, a wide body of work has looked into the way that fingerspelled words reduce, addressing in particular how this is related to frequency as well as mention number. And so among this, a number of studies on fingerspelling in ASL have shown repetition reduction continuing across multiple mentions. So for example, Deborah Wager's work showed a significant increase in signing rate between 2nd and 3rd mentions. And Ryan Lepik, at looking at the relationship between fingerspelling reduction and frequency, he found that low frequency tokens continue to reduce across multiple repetitions. And all of these projects together found that as words are repeated, we see an increase in letter co-articulation across mentions, as well as letter deletions, for example. In contrast, repetition reduction in the speech research has been framed a little bit differently. It's been framed in terms of the givenness of a word in discourse. And this research is built on early studies, such as that of Fowler and Hossam, which found that repeated mentions of a word were reduced in duration with respect to their first mention. A series of studies on repetition reduction following this then confirmed these early findings. Now, typically, it's important to note that the effect of repetition within this research has been treated as binary. And so reduction is only sensitive to whether a word has happened before in discourse. The question of whether the repetition effect is binary or scalar was tested in Bell et al. 2009, and they found that reduction did not significantly increase after a word's second mention. So we see this disconnect then between the speech research and the previous research on ASL fingerspelling. There is also some evidence that suggests that the distance between repeated words might also influence their duration, with increased distance being associated with less reduction. Theoretical models of language production intended to explain repetition reduction effects, as well as more general predictability-based effects, have posited different mechanisms to explain reduction. And many of these models posit that since we get information about a word's identity, not only from the linguistic signal itself, but also from the discourse context, which includes information about whether a word has been mentioned before, when there are contextual information in the discourse that already provides information about what's going to be articulated, the language producer can expend less energy in clearly articulating each item. And so if a word has been mentioned previously in the discourse context, the language producer doesn't have to expend as much energy in articulating an item, and they will still remain intelligible. So if this is the case, we expect that even as we see reduction continuing, it might be, this continuing reduction might be limited to maintain comprehension. Importantly, for this particular project, part of the contextual information that producers use in determining how they produce a word is the givenness of the word. And so we want to know what kind of givenness information is used for production. So we want to know for language producers, are they in fact attuned to simply whether a word has been given or not given? Or instead, is there a slightly more detailed representation of a word's givenness? So for example, does this encompass how many times a word has been mentioned and the time since last mention? And that's what we'll be testing today. So for the predictions for this study are as follows. And note that these are not two competing predictions. These are simply two distinct research predictions. The first prediction is that fingerspelled words will continue to reduce past second mentions, but decreasing in the amount that they reduce as they're repeated. So we don't expect that reduction will continue ad nauseum. The second prediction is that variation in repeated word duration can be accounted for through the distance between mentions, with words that are farther apart exhibiting less reduction. Moving on to methods, the dataset used in the present study is drawn from a larger crowdsourced dataset of fingerspelling videos from online publicly accessible videos from sites such as YouTube, for example. And these videos encompass a wide range of genres and topics, including video blogs about politics, cooking, health, as well as news and educational videos in ASL. And due to the wide variety of genres, the signing in this corpus then ranges from semi-scripted to spontaneous. The reduction data set took words from the wider corpus that were repeated between 3 and 5 times. So high frequency lexicalized sequences, we did end up excluding from the data because these lexicalized items have slightly different articulatory properties than those found otherwise in fingerspelling.
Just a second, we lost the interpreter again.
Of course.
All right, are we able to see the interpreter now? We're getting a not yet from an audience member that they can't see the second.
Okay, let me know when you can see the second interpreter.
Yes, now.
All right.
Just as, wait, I'm getting one audience member saying that they can't see I'm getting some audience members saying that they can see them and others saying that they can't. Both interpreters should be spotlighted.
Hi, this is the interpreter. Only need to spotlight one interpreter at a time. When we switch out, we're shutting off our video.
Okay. Is everybody able to see the interpreters now? Once she gets spotlighted, yes. All right. She is spotlighted now.
All right, are we set? I can't see the chat. Can everyone see the interpreter now?
Apologies. I think part of the problem is when I speak, do we know if it might be an issue with folks' view, if they have gallery view versus speaker view? Does that change it at all? Okay, it is now on gallery view on my end. Are people able to see? I am switching up the views on my end. Blake, do you know why we might be getting some participants saying they can see the interpreter and others not? You should be able to resize. I believe you should at least be able to resize the slides. I'm really not sure. I haven't been changing the settings. The PSAV has been.
Hey guys, just so you know, I'm sorry, my name's Noah. I'm working with Blake. We're trying to figure this out right now. So just bear with us one moment.
Thank you.
Okay, everybody, I just want to check. So can the participant who needs the interpreter see the interpreter? Can we get a confirmation of that in the chat? And Leah, I see that she's chatting here. Leah, do you perhaps have two screens where perhaps a window is in front of another window? Leah, are you on perhaps a Mac or an iPad? Yeah, Mac always offers some issues sometimes when we try to control the view. I'm going to have Blake try to turn off our host view because we normally dictate the way that you see it, but we're going to try to turn that off so that you can readjust panels on your screen. So we'll try that and see if that helps. Excellent. Thank you, guys.
Yay.
Very
All
sorry
right.
for the difficulties.
Okay, Aurora, if you want to keep going, I did pause the time and hopefully we won't get kicked out when time is up, but go ahead.
Okay, that sounds good. And can you still see my slides?
No, have you reshared your screen?
I will do so.
There we go.
Perfect. Okay, so the data set for this project took words from the wider corpus that were repeated between 3 and 5 times. And the smaller data subset that we took for this project did exclude lexicalized fingerspelling because they have distinct articulatory properties that are not otherwise found in fingerspelling. The data set of repeated tokens comprises a total of 477 individual fingerspell tokens from 103 separate words. And these sequences are from 34 different signers. We completed data annotation in ELAN, E-L-A-N, and captured the timing and letter content of the target fingerspelled tokens, as well as their phrasal position. And for phrasal position, we annotated whether something was phrase final or in another position in the phrase. The analysis was conducted in 2 parts. And we analyzed the data using linear mixed effects models. In the first part of the analysis, we tested the effect of mention number, looking specifically at mentions 1 through 5. And in the second part of the analysis, we wanted to specifically look at the influence of the distance between mentions on word duration. Since distance between mentions is not applicable for the first mention of words in the data set because there's no mention preceding them, we only use this subset of the data for the second analysis. First, we'll look at the general trajectory of word reduction across mentions. And for this particular analysis, we compare the duration of each mention to all of the ones following it. And here is just a reminder of our initial predictions. And beside this is a plot that shows the average mean length of words across repetitions. And then the effective mention number was tested in the analysis by comparing the mean of each mention to the mean of the mentions following it. Results of the analysis show that the difference between the mean of the first mention and the mean of the subsequent mentions was significant. Additionally, the difference between the mean of the second and the subsequent mentions was also significant, with the value of the estimate decreasing between this comparison and the previous one. The difference between the durations of the third and subsequent mentions was not significant, nor was the difference between the fourth and subsequent mentions within the model. Within this analysis, we also wanted to account for variation in length due to phrasal position, based on previous work on length and prosodic position in ASL that showed that lexical signs lengthen phrase finally. And a plot showing the difference between tokens in phrase final and other positions can be seen here. It shows the means for phrase final tokens and means for tokens in other positions in the phrase at each mention number. Within the analysis, there was a significant effect of phrasal position, with phrase final tokens being significantly longer than words in other positions in the phrase. We then wanted to test if not only repetition number, but also the distance between repetitions influenced word length, predicting that if words are farther from their previous mention, they will show less reduction and be longer than those that are closer together. And recall that we're using data from mentions 2 through 5. The plot you see here is a plot of all the duration data from these mentions 2 through 5, with the distance between a word and its previous mention plotted on the x-axis and the duration plotted on the y-axis. The data shows a positive trend indicated by this regression line, where as time distance from a previous mention increases, word length also increases. And when incorporated into the model, we found that the distance between mentions had a significant positive correlation with duration in the model. And this means that if words are repeated farther apart, they reduce less. Now, what are then the implications from these findings? Firstly, these confirm findings from previous work, which is excellent. Finding that mention number, not just whether or not a word has been mentioned before, is important in influencing the length of fingerspelled words. Additionally, we found final lengthening. So this aligns with previous studies. And we also find, crucially, that the reduction effect is not uniform across mentions. And so while reduction did continue past second mentions, it did decrease in the amount that it kept reducing and eventually wasn't reducing anymore in a significant way. Additionally, we added the dimension of between mention distance, showing that this also influences duration. For our wider models of language production, I think that most crucially, this tells us about what level of information is accessible to and usable by language producers. And this is something we would expect to be true cross-modally. So we can see that language users at some level are sensitive to detailed information about a word's givenness in a discourse. And this information encompasses not only how many times a word has been mentioned, but also how long it has been since the last mention. So to wrap up, by using ASL fingerspelling as the lens through which we examined word reduction, we've been provided a more complex view of how word repetition can contribute to word length. There are a number of questions that remain that we weren't able to answer, at least not yet. So for example, we don't know how much of this reduction is an effective modality and how much is a result of the fingerspelling system. And we also don't know, so we can guess that reduction is limited to retain comprehension, but we don't in fact know how repetition reduction does in fact impact comprehension. Many thanks to my collaborators, co-author, and project team for support and feedback on all of this. Thank you.
All right, thank you, Aurora. I've been told that we will be able to stay in the room past the end time, so we should be able to use our full time for questions here. Again, you can submit them through the Q&A or by raising your hand. All right, Susan Fisher. I'm asking you.
Hi. Very interesting talk. And I was wondering if you were aware of some very early work, you know, maybe 40 or 50 years ago by, I think, Glucksberg and Danks, where they had people repeat a story or repeat a long description of somebody in a story. And then every time it was the large phrase was repeated, it got shorter and shorter and shorter. So I think this is a general trend. It's not just with fingerspelling. I'm sorry, I tried to find the reference and I couldn't, but it might be worth looking into.
You said Glucksberg and Danks?
Glucksberg, Glucksberg.
Glucksberg. Excellent. Yeah, I know there's been research looking at reduction on a phrasal level showing that, for example, people would reduce, if you're referring to like a reference, you know, like someone's name, for example, as you subsequently mention a particular referent, you're more likely to use something shorter like a pronoun. but I hadn't seen
Yeah.
anything on a full phrasal level. So that's an interesting thing that I should.
Right. So you might have something with a relative clause, and then you would end up just with the noun phrase, something like that, or
Oh,
even shorten the word. You can't see me gesturing, but anyway.
No, that's an interesting angle to look at too.
But
And
I think it's something about information load, I'm sure. You know, because if it's been mentioned, then you don't, as you said, you don't need to give it quite as much emphasis the next time.
Mm-hmm. Yeah, that makes a lot of sense. Balancing information load across the signal.
Right, we have a question in the Q&A from Albert Bickford. When fingerspelling is used for emphasis, duration often increases notably. How did that affect your analysis?
Oh, so this is an excellent question. And this is not something that we looked at in this particular analysis, but I can imagine that if we add additional annotations for words that would have been emphasized in our data set, we might see this duration increase. I expect at the moment any sort of duration increase as a result of emphasis probably just contributes to some additional variability or noise in the data, but I think we could probably, if we include this in our model, have a better model that fits the data if we're looking at this as well. So yeah, we didn't include this in our this present analysis, but I think that's an excellent angle to also include.
I see a question in the chat from Richard Meyer. Could there be an effect of abbreviation rather than reductions? Some sign languages use just the first letter on the second mention.
That's also an excellent question. And if I don't quite address your question, let me know. But I think that definitely could have an effect as reduction, and this could be. I'm not sure that this is something we would have seen in this current data set, because I think if something had reduced solely to its first letter, I'm not entirely sure we would have counted it as belonging to the same repeated full word. But that is going back to Susan's question, I think is another way that we see this reduction happening, I think at different levels across the whole grammar. So, you know, we might see a word just getting shorter and shorter, and we might see some sign languages just reducing something to the first letter. But I think the abbreviation also certainly falls under this purview, under this question rather.
Any other questions? All right, well, thank you to our speaker, and I think we'll move on since we are a little behind. Feel free to continue to use the question to answer box if anything else comes up that you might have questions about. Our next speaker is Seon-Yoon Kim from Cornell University, who's going to be talking about the effects of speech rate on the phonetic correlates of syntactic structure. And we can see your screen, so you can go ahead. Yeah.
Okay, so hello everyone. My name is Seung-In, and today I'm going to be talking about the effects of speech rate on the phonetic correlates of syntactic structure. And everybody can see my slide, okay, right? Okay, assuming that is okay. So yeah, So a number of studies have argued that prosodic structure is closely related to syntactic structure. And specifically, it has been asserted that the boundaries of prosodic units, so intonational phrases or intermediate phrases, are mapped to the left and right edges of syntactic constituents. And for example, here's a prosodic organization of two distinct syntactic structures, non-restrictive relative clauses and restrictive relative clauses, based on Selkirk's theory proposed in 2005. And these examples give an idea on how syntactic units are mapped to prosodic units. So for example, in non-restrictive relative clauses, the main clause subject, a Mr. Hot, constitutes a little IP, an intermediate phrase, and the relative clause, who knows Mr. Raw, makes another little IP, and they together constitute an intonational phrase, a big IP. And the main clause predicate, often plays tennis, constitutes another big IP. And if you compare the prosodic phrasing of NRC and RRC, although the two structures have almost identical lexical content, as they differ syntactically and also semantically, their prosodic organizations are different. So in NRC, the relative clause, who knows Mr. Rob, simply gives extra information about the referent, Mr. Hot, which is similar to a parenthetical. So it constitutes a separate prosodic unit on its own. But in RRC, the relative clause is crucial in identifying the referent from a set of possible referents. So it constitutes a prosodic unit together with the main clause subject. So theories of syntax prosody interface differ on the specific prosodic organizations of these two structures, but they all have in common that the syntactic units are in some way mapped to prosodic units, and different syntactic structures, such as non-restrictive and restrictive relative clauses, are mapped to different prosodic organizations. The current study focuses on this mapping between syntax and prosody, but the main goal of this study is to find phonetic evidence. So while many studies, including Selkirk or Nesper and Vogel in 1986, make predictions on how syntactic structures are mapped to prosodic organizations, there haven't been a lot of investigations on how phonetic measures vary as a function of phrasal boundary and syntactic structure. But if syntactic structure is mapped to categorical differences in prosodic organization, we can expect that articulatory and acoustic measures at boundaries would differ. And in addition, this study investigates how syntax prosody mapping is affected by continuous variation in speech rate. To investigate these questions, the current study makes use of the syntactic contrast between non-restrictive and restrictive relative clauses in English. And two hypotheses are tested based on Selkirk's prediction. So the first one is the boundary position differences, and the second one is the syntactically conditioned prosodic differences. The first hypothesis examines whether prosodic boundaries before and after the relative clause are produced differently within each syntactic structure. So I refer to the boundary before the relative clause as B1 and the boundary after the relative clause as B2. And we can predict that the kinematic and acoustic measures at B2 would be stronger, so longer durations or larger movements, than the measures at B1. And notice here that I named this hypothesis as boundary position differences, instead of naming it also as syntactically conditioned differences. This is because the difference between B1 and B2 can arise due to syntactic reasons, but they may also arise simply because B1 occurs earlier in the sentence than B2. So I remain kind of agnostic about these differences being syntactic in nature and instead refer it as boundary position effect.
Excuse me, can you speak just a little bit slower? Thank you very much for the interpreting process. Thanks a lot.
Okay, sorry. Okay, so yes. The second hypothesis examines more syntactically induced differences, comparing the boundaries across NRC and RRC. So here at each boundary, so at B1 and B2, kinematic and acoustic measures in NRC will be produced more strongly than the measures in RRC. And it should be noted that in examining both hypotheses, I'm not necessarily interested in, like little IP occurs at B1 and NRC, and a word boundary occurs at the same location in RRC, but I'm just comparing the strength of the prosodic boundaries at different locations with acoustic and articulatory measurements. This way, the results from the current study are generalizable to other theories of syntax prosody interface who predict distinct prosodic structures for these two types of sentences, but do not necessarily make the same predictions as Selkirk. In order to examine how these differences interact with speech rate, I elicited a continuous variation in speech rate and examined how phonetic measures and boundaries vary by rate. Although there have been a number of studies which examined the effect of speech rate on prosodic phrasing, these studies varied rate in a categorical way. So like on the left side of the arrow, previous studies gave instructions such as speak fast or speak slow to elicit different speech rates. But I think this can be problematic as different speakers are likely to interpret instructions such as speak fast or slow in different ways, which kind of makes it hard to conduct analysis across speakers. Also, when speakers see those instructions, they might adopt categorically different behaviors, which they otherwise would not. So rather than using these kinds of categorical cues, I instead use a moving visual analog, which is the red box here on the right side, that moves across the screen at different speeds. By eliciting a continuous variation in speech rate, we can more precisely examine the nature of boundary position effects and syntactic effects. So we would be able to investigate whether the differences are found at all speech rates, like in figure 2, or at certain rates, as in figure 1. So moving on to the details of the experiment, I collected data from 12 native speakers of English, and for 6 of them, the only acoustic data were collected, and for the other 6, articulatory data, so the EMMA data, were collected in addition to acoustic data. And in both cases, the experimental task was identical, and participants read 2 types of RCs at varying speech rates. Typically, the 2 RCs are distinguished just with commas. So NRCs are marked by commas before and after the relative clause, but RCs are not. But in order to draw more attention to syntactic and semantic differences between the 2 types of RCs, the contact sentence was provided before the target, and the determiners were added at the beginning of the target sentence. And there were 6 blocks in the experiment, and each block had 40 trials. And participants produced only 1 type of RC throughout the block, and the blocks alternated between the 2 types of RCs. This shows how each stimulus was presented. So participants first see the contacts and target sentence on the screen, where they were instructed to read them silently. And then the visual rate cue appears, and this red box moved from left to right across the screen at a constant rate. And the period of time it took for the rate cue to move across the screen varied in 10 steps. When the cue stopped moving and the gray box changed to green, participants were instructed to read the target sentence in a way that reflected the speed of the visual analog. So they had to wait until the cue stopped moving before initiating their response. So it was not the case that participants were reading the sentence along with the visual rate cue. Also, they were instructed to use their impression of how fast or slow the cue moved and reflected in their production, rather than exactly memorizing the speed of the cue. As I said, the rate cue moved in 10 different speeds, and the speed of the cue varied randomly from trial to trial. Also, participants were explicitly instructed not to emphasize the names at phrase boundaries. To check whether the participants did vary their speech rates, I conducted a post-hoc analysis on the range of the empirical speech rate within each participant, which was measured as the duration of the target sentences. The figure here shows the data from 6 speakers in the articulatory sessions. So the x-axis in each figure is the time it took for the rate cue to move across the screen, so it represents 10 different speech rates. And the y-axis is the average utterance duration at each rate. And we can see that a quite wide range of utterance durations were observed for all participants, which shows that the rate cueing method was successful in eliciting a wide variation of rate. And in the analysis, I used empirical speech rate, so the duration in the y-axis, instead of the cue duration in the x-axis, as a measure that represents speech rate. This is because the empirical measures better reflect the continuous nature of speech rate and also better account for between participant variations in speech rate. The target words in the experiment are the names that occurred at two prosodic boundaries, which ended either in B or D. For acoustic analysis, I measured the duration of the coda, vowel, and rhyme portion of the target word. And in addition, I measured a transboundary interval, which is a hybrid articulatory and acoustic measure that's defined as the time from the target achievement of the coda closure to the acoustic onset. Target achievement of the coda closure to the acoustic onset of the post-boundary vowel. So this is similar to pause duration, but it adds like extra milliseconds before and after the pause. So the TBI at B1 in this example would be the time from the target achievement of the alveolar closure in hod to the acoustic onset of the vowel U and hu. For articulatory analysis, the movement duration and amplitude of the closure and release gestures of the target word coda were measured at each boundary. And for all these acoustic and articulatory measurements, a mixed effects linear regression was conducted to determine the boundary position and syntactic prosodic effects. Okay, so here's a summary of the results. So our first hypothesis, the boundary position effect, was robustly found in all measurements. But the second hypothesis, the RC type effect, was found only at B1 in most variables. Only the TBI showed the RC type effect both at B1 and B2. Starting from the articulatory measurements, analysis of movement duration and the release phase of the coda showed a strong boundary position effect. So the lines in the figure represent polynomial fitting of the data, and in both RCs, the B2 lines were placed higher than the B1 lines, showing the boundary position effect. Regarding RC type, analysis of movement duration showed mixed evidence, as the difference between the two structures was found only at B1, but not at B2. At B1 here, NRC, the blue line, was produced more strongly than RC. And note here on the left side, in the closure movement duration, no boundary position or RC type effects, none of these effects were found. And crucially, both boundary position and RC type differences interacted with speech rate. So the difference between the movement durations at boundaries was reduced as participants speak faster, and they merged at the fastest extreme. Analysis of movement amplitude shows similar results with movement duration. So regarding hypothesis 1, strong boundary position effect was observed in both syntactic structures, and they all showed a larger boundary at B2 than at B1. Also, the RC type effect was observed at the release movement amplitude, but the effect was found only at B1, and here also NRC was produced more strongly than RC. In terms of the effective speech rate, the difference between the RC type at B1 disappeared at fast rates, like in the movement duration, but speech rate did not strongly affect the difference between B1 and B2, as the boundary position effect was found at all speech rates in both RCs. The acoustic measurements also showed a strong boundary position effect, and analysis of the coda, vowel, and rhyme durations shows similar patterns, and you can see the results of the coda duration in the left figure. And the right figure shows the results of the TBI measure. And in all acoustic variables, B2 showed a longer duration or scaled more strongly with rate than B1. For RC type effect, the segment duration showed RC type differences only at B1, so as in here, but in TBIs, they show significant differences at both boundaries. So B1 and NRC was placed higher than RC, and B2 also. In all cases, B2 was produced more strongly than B1. Also in the acoustic measurements, boundary position and RC type effects were not found at all speech rates. Okay, to sum up, my first hypothesis, the boundary position differences were robustly found in both articulatory and acoustic measurements. And in all cases, B2 was produced more strongly compared to B1. The second hypothesis, the syntactically conditioned differences showed mixed evidence, as the effect was found at the boundary before the relative clause, but not after the relative clause. And only the TBI showed a strong RC type effect at B2. I also conducted by-speaker analysis, and some participants did show a significant difference between the two structures at B2 in variables besides TBI, but the effect direction differed. So one speaker produced NRC more strongly than RRC, but the other speaker showed the opposite. And in addition, in most variables, the boundary position or RC type differences were not found at all speech rates. Regarding the articulatory analysis, we could observe the boundary position effect or RC type effect in the release phase of the coda, but not at the closure phase. And this, I think, may be related to the fact that the release gesture is closer to a prosodic boundary than the closure gesture, and therefore the measurements in the release phase show stronger boundary-related effects than the closure gesture. In terms of the RC type effect, contrary to my hypotheses, most variables did not show a strong difference between the two types of RCs at B2, but the TBI showed a significant difference. And one possible interpretation is that the segment durations or segment articulations have an upper bound on how much they can be lengthened, but the TBI measure has relatively more freedom in terms of the lengthening. So at B2, where a large prosodic boundary is expected in both syntactic structures, participants lengthen the segment durations in both structures such that they already reach the upper bound, and we cannot really observe the difference between the two types of RCs in those variables. But as speakers have more freedom to manipulate or lengthen the boundary intervals, the differences are observed in TBIs. But at B1, where relatively a small boundary is expected, we can see the difference between the two types of RCs in both the segment measures and TBIs. Overall, this study found phonetic evidence for the mapping between syntactic structure and prosodic structure. And not only the two boundaries were produced differently within each utterance, but also NRC and RRC were different, especially at the boundary before the relative clause. And furthermore, this study found that the speech rate is highly correlated with the mapping between syntax and prosody. By eliciting a continuous variation in speech rate, we could examine how the differences between the boundaries vary along the rate continuum, rather than just a few random points in the continuum. And there are obviously more things to investigate to get more complete picture of how syntax affects phonetic measures. One most important factor would be F0. I haven't conducted F0 analysis for this study, but F0 is definitely something that's going to play a crucial role. And other factors such as movement velocity and velocity together with movement amplitude or articulatory measures besides coda gesture should also be investigated. Before I end this presentation, I'd like to talk a little bit about the related project that further investigates how phonetic measures vary along the speech rate continuum. In the previous slides, we saw that the differences between prosodic boundaries vary as a function of speech rate. But the follow-up question that I had was how phonetic measures at each boundary, so not the comparison between the boundaries, but each boundary, so in each line, vary as a function of speech rate. So in the previous analysis, I kind of presupposed that they vary gradiently. So I conducted linear regression analysis, but in here, I wanted to investigate whether that assumption is really true. So many theories argue that at fast rates, prosodic boundaries are deleted or demoted to a lower boundary. And my question was, do phonetic measures vary categorically? So at certain rates, they're produced as a big IP, and past a certain threshold, they're produced as a little RP, or do they vary gradiently along the speech rate continuum? For example, the figure here shows the TBI measure of one participant. And my question is whether we see a gradient variation like figure 1, or more categorical variation like 2. In case like 2, we can interpret this pattern as there are two categories in the continuum. So for instance, little IP and big IP, and each category exhibits the speech rate effect. So I conducted this study with my advisor, Sam Tilson, and in order to answer this question, we conducted a set of analysis using a regression mixture model, which assigns data points to a predefined number of categories based on their probability. So it's basically similar to a clustering. And in every data set, I fit a regression mixture model and a linear model, and then compare the two model fits using the AIC values. So this way, I could determine whether the given data set is better explained with one category, so similar to figure 1 in the previous slide, or two categories as in figure 2. And I ran this analysis for each boundary in each syntactic structure separately in each participant. And the results found in general weak evidence for the categorical change. About 20.6% of the data show substantially better fit in the regression mixture model than the linear model. This suggests that the phonetic measures at each boundary vary gradiently rather than categorically along the speech rate continuum. Overall, together with the results from the previous studies, these analyses show the importance of fine-grained variation in speech rate to assess prosodic variation. Thank you for listening.
All right, thank you. We have about 8 minutes for questions. So again, you can submit those through the Q&A or by raising your hand, and I will unmute you to allow you to talk. Yeah, Jason Shaw.
Hi, that was really interesting. Thanks for the talk.
Thank you.
I was just wondering that the last part, if you had gone back and taken that kind of 20% of the data that looks like something categorical is happening,
Mhm.
and then taking that out to see if you get an effect of the different relative clause types without the category, I guess in those two sets of data.
Mhm. Yeah, so for this analysis, I didn't really, so for this analysis, I just focused on whether we can see categorical versus gradient variation. But the next step, I think, is incorporating this categorical versus gradient variation into syntactic differences, so that whether we see a different variation pattern across different syntactic structures or different boundary positions.
Nice. Do you have did you say what you think the different categories are for the, I know this is a small part of the data, but I found that very interesting.
Sorry, can you repeat the question again?
Did you do you have an interpretation for of the 20% of the data that showed a better fit with the mixed regression model? Do you have an interpretation for what that category might be? What the category is? So this is like a bifurcation, right? So as you scale speech rate, you get like a categorical shift.
Yes.
Rarely, right? And just in 20% of the data. Do you have a interpretation for what that category might be?
Okay, so I looked more into that 20% of the data, and it was found more often at B2, so the post-relative clause boundary. So I guess it's more of like a phrasal unit difference, but at this point, I don't have like any further evidence what that category would be, whether it's like little IP or big IP, and whether it's just word and little IP. I don't have evidence for that. Maybe I can look into like tonal patterns or more, I have to do more analysis. But yeah, it's just the finding that I had for the analysis at this point is the B2 had more categorical variation. So I guess it must be a larger like phrasal unit.
Right, great, thank you.
Thank you.
Other questions? I have possibly a quick one. So you mentioned the TBI measurement, I think, includes both the pause and like from the onset, I think you said, of the previous consonant. Can you talk about sort of why that measurement is sort of including that little bit there as opposed to just looking at the pause length?
Yeah, sure. So the TBI measure, I defined it as the time from the target achievement of the coda closure and to the next acoustic onset of the vowel. The reason why I added that extra millisecond is when I was labeling, like after I did forced alignment, when I was checking the data, it was kind of hard for some cases to distinguish the low acoustic energy for the D voice codas of the target word and the complete silence of the pause. So that's the one reason that we decided to like add a little bit more. And the other thing is, since this analysis, I use linear regression for the main tool. And for posturation at fast rates, in most cases, the value was like 0, no silence was detected. So then like I was thinking whether like having a lot of 0 values, does it really make sense? Is it like really fair to use linear regression? So that's why I decided to add a little bit more to posturation.
Okay, gotcha. Any other questions? All right, again, you're welcome to put, if you think of any others, into the Q&A, and the panelists can potentially get to them after. So I think we'll go ahead and move on to the last talk of the session, which is by Soo-Yeon Im and Jennifer Cole. Jennifer Cole will be presenting on discourse meaning and perception and production of prosodic prominence.
Okay, I'll just share my screen. Hopefully that works. Okay, are you seeing my title slide? Let's see.
Looks good.
Okay, thank you. No, I'm not seeing you, so okay. So yeah, this my co-author Soo-Yeon was intending to present this talk, but things happened and it turned out that she's getting married today, or she probably is married by now. So we made an appropriate switch. So, I'll try to my best to answer questions. Okay, so I'm talking today about prominence. So in a spoken language, some words stand out as more prominent than neighboring words, and listeners perceive prominence distinctions in relation to phonological factors like phrasal stress and pitch accents, and their corresponding acoustic cues, for example, in measures of pitch, intensity, or duration. Prominence is a relative notion, so we say that a word is more or less prominent relative to other words in the same utterance or discourse segment. And prominence distinctions among words are based in part on distinctions in the information status of a word relative to its discourse context. So words that are given in the prior discourse have low information status relative to words that contribute new information. And between these poles are words that are bridging, so inferable from the context, or words that are unused. In other words, words that are assumed known, but not explicitly mentioned. And these distinctions define an information status ranking from given at one end to new at the other. Contrastive focus is another dimension of discourse meaning that relates to informativity. A word with contrastive focus conveys greater information than a word without focus. And we use the term information structure to refer to both givenness and focus. So here's a quick example. The information structure of a word varies according to its discourse context. So consider this little story of 3 sentences. Our sister Jamie spent all day in the kitchen. She knew it would take hours to make the marmalade. Our Nana loved the marmalade. So in the 3rd sentence, the word marmalade is given because it's been mentioned in the preceding discourse context. But the same sentence, the same final sentence, our Nana loved the marmalade, can occur with a different context. So here I'm changing just the 2nd sentence in the story. She especially enjoyed making homemade preserves. Our Nana loved the marmalade. And now the word marmalade has not been explicitly given in the preceding discourse. However, it's accessible due to the semantic relation between marmalade and homemade preserves. Or the preceding discourse context may give no information that relates to marmalade, in which case the word marmalade is discourse new, as in this example. Or the preceding context might have a word which is in a contrastive focus relationship with our target word marmalade. So our father loved the strawberry jam, our Nana loved the marmalade, and in this case, the word marmalade has contrastive focus. So for English and other languages, including West Germanic languages, distinctions in information structure are reflected in corresponding distinctions in prosodic prominence. So words that are contextually given or not focused are generally less prominent than words that are inferable or unused, which in turn are less prominent than words that are discourse new or focused. So in terms of the example we just stepped through, the word marmalade might be produced with very different pitch accents, with different pitch movements, as illustrated cartoonishly here, with also likely differences in the duration of that word or in intensity or other measures of acoustic prominence. So let's see how this works in speech production. A speaker maps from the information structure status of a word to its phonological and phonetic prominence. And in perception, the listener has only to invert that mapping, interpreting the referent of an expression from its prosodic manifestation. But the simple picture is complicated by the observation that the mapping between information structure and prominence is not deterministic. So many-to-many mappings between information structure distinctions and prosodic distinctions are reported in research on speech production. And accordingly, a listener may accommodate variable mapping between prosodic expressions and discourse meaning, possibly guided by contextual factors or speaker idiosyncrasies. In addition, experimental evidence shows that listeners apply top-down processing in perceiving prominence, imposing expectations about the prominence of a word or of a linguistic expression based on its informativity, which would include its focus condition, its givenness, and other measures of predictability. So for example, if a word in an utterance is recognized as discourse given, the listener may be biased to perceive it as less prominent. And the listener has to then reconcile their expectations. If the word that they're expecting to be less prominent is actually heard in the speech signal with low phonological and phonetic prominence, then the expectations and the signal converge on a common perception. In this case, the word marmalade would be perceived as less prominent than other words in its vicinity. But the acoustic cues may conflict. There may be a mismatch between signal-based cues and top-down factors. And we're interested in understanding the relative contribution of the acoustic signal and discourse context, and specifically information structure, on the perception of prominence in such cases. Should be perhaps some confusion there for the listener. Okay, so our research question is the effect of information structure on prominence in speech production the same as the effect of information structure on listeners' perception of prominence, especially given that the expectations coming from recognizing the information structure condition of a word based on the discourse context may be mismatched with information coming in from the speech signal. So in this study, we investigate the relationship between information structure and prominence through the analysis of word prominence ratings performed under two conditions that represent prominence experienced when listening to speech and prominence experienced in internalized speech production. So we ran two experiments, each with 30 native speakers of American English, and they were rating prominence of words. And the materials that we used for this was a complete TED Talk, a short TED Talk, which is entitled "Try Something New for 30 Days." It has 361 words total, so this is a shorter TED Talk. It's kind of a motivational speech, and you can find it on the internet. Participants in our experiments were asked to mark words as prominent, given a transcript of the TED Talk. And this was done, each participant participated in two different experiments of prominence rating, which were administered at a 1-week interval. In one experiment, they were listening to the TED Talk, an auditory presentation of the TED Talk, while also viewing the text. and marking words as prominent based on the combined information from the auditory signal and the text. In the other experiment, they were presented with the text only and no audio signal. So they didn't hear the TED Talk, they just read it on the screen, but they still had to make the same judgment about whether words were prominent. And we asked them to do this on the basis of imagining themselves delivering this talk, this TED Talk. And so we're intending then that this is sort of an imagined prominence ratings, capturing the participants' internalized production. The prominence ratings themselves were done using the rapid prosody transcription method. And in this method, participants view the text of the speech sample, in this case, a TED Talk, that's presented with no punctuation or capitalization. And they're asked to mark prominence and boundaries, so prosodic prominence and prosodic boundaries successively in two separate sort of rounds of prominence rating on the same text segment. And they do it in each case, they're marking prominence or marking the location where they judge prosodic boundaries by clicking on words. So this is a web-based application. And once they click on a word, the word turns red in the prominence rating task, or a little vertical bar appears after the word in the boundary rating task. And each participant is going to go through and rate the same materials for prominence and boundaries in successive sweeps through the speech materials. Participants can click multiple times on the same word. If they change their mind, they can select and deselect it. In the perception experiment, when they're actually hearing the auditory signal, the audio plays through twice in entirety, and they can rate the words. It's a quasi real-time prosody rating in that case. The participant does not control the playback, so they can't stop and start the audio. They have to just mark the words they hear as prominent, and then in the next task, mark locations of perceived boundaries as the speech goes in real time. So we also annotated the materials for their information structure condition for each word. And for this, we used the reflex scheme developed by Arndt Riester and Stefan Baumann. And in this scheme, information structure distinctions are annotated in three different domains. At the referential domain, we're marking givenness relations between referring expressions relative to the discourse context. So this is considering the referent of a word. At the lexical level, we are marking givenness or accessibility relations between content words relative to the discourse context. And so referential givenness and lexical givenness don't have to agree, and that's illustrated by this example here, taken from Baumann and Riester's 2013 paper. So in this passage, we have yesterday, a friend of mine prepared a lasagna for me. I found it hard to enjoy the tasteless stuff. So the underlined expressions, lasagna and tasteless stuff, refer to the same thing. So the referent is new on the first mention of lasagna, but on the second mention of tasteless stuff, referring to the same entity, it's given, referentially given. But both the word lasagna and the words tasteless and stuff are new. They're mentioned only once in this passage, and so they would all be assigned the value lexically new. In addition to referential and lexical givenness, this scheme also marks contrastive focus, which they call an alternative level, marking contrastive focus based on salient semantic alternatives. As in the example, did you call John? No, I called Mary. So in that case, Mary is the contrastive, is the contrastive referent with respect to John. Okay, so we were looking at variation in the participants' prominence ratings of each word in the TED Talk. And we modeled that variation with logistic regression. So the dependent variable is a binary prosody rating, a prominence rating for each word, where the word gets the value 0 if it was not marked as prominent by a particular participant, and it gets marked 1 if that participant marked it as prominent. And so for each word in the TED Talk and for each participant, we have a value of 0 or 1. And we're trying to predict this prominence rating based on two predictor variables. One is whether the rating was made in the perceived prominence experiment or in the imagined prominence experiment. And the other predictor is the information structure label. And this actually breaks down into 3 separate predictors, one for referential givenness, one for lexical givenness, and one for alternative focus. And there are multiple levels within each of the referential and lexical givenness. For alternatives, there's just a distinction between focused and not focused. We also looked at interactions between the experiment and the information structure label. So our hypothesis is that the effect of information structure on prominence ratings will differ for perceived and imagined speech. And there's sort of 2 scenarios that we are imagining for the outcome of our analysis. On the one hand, we may find stronger effects of information structure in the ratings done while listening to the speech, so in the perceived prominence compared to imagined prominence. And we reason that the presence of acoustic cues might reinforce distinctions that are salient from the discourse context. On the other hand, we may find stronger effects of information structure on the imagined prominence, because in that condition, there's no, the rater doesn't have any access to how the actual TED Talk speaker, pronounced the word. And so they can rely exclusively on the discourse context. And there's no opportunity for interference from possible mismatches between acoustic cues to prominence and information structure conditions for particular words. So we weren't sure which way the difference would work out, but we expected that we are hypothesizing there'll be a difference. Okay, so this is showing you the distribution, the empirical distribution of the average prominence ratings by words under the 2 experiment conditions. So it's just, you just sum up all of the occurrences of a prominence rating for a word, divide that by the number of raters, and you get a number between 0 and 1. And you can see that this distribution is at the low end here, so that this is telling us that for most words in our materials, there weren't very many raters who were considering that word to be prominent. But the distribution looks quite similar under the 2 experiment conditions. And in fact, our statistical model showed no significant difference in the likelihood of prominence ratings based on perceived versus imagined speech. But what we're actually really interested in is the contribution of information structure to the prominence rating. So let's look further. So here are the results for the effect of information structure on the predicted likelihood of prominence ratings from our model. And here we see significant main effects of information structure, and they're in the expected directions. So if we look first for referential givenness, words that are referentially new or unused, the unused categories for like proper names, like Barack Obama, so it's may not be new to the discourse, but they have higher, they predict a higher likelihood of prominence ratings. Words that are lexically new and not previously mentioned in the discourse also are more likely to be rated as prominent, and words that have contrastive focus, the alt label on the right, also are more likely to be marked as prominent, all as expected. On the other hand, words that are referentially given or inferable, words that have a lower likelihood of being rated as prominent. The lexical none category stands for words that are in a function word or discourse marker set. So they are much less likely to be rated as prominent. And then non-focused words are less likely to be rated as prominent. So these effects are present as main effects independent of the experiment condition. So here's the part we were interested in. Are there differences in the contribution of information structure to prominence ratings, depending on whether you're hearing the speech or it's an internalized production that you're rating? And here what we find is that differences in prominence, in the likelihood of a word being rated as prominent, are enhanced in the perceived condition relative to the imagined condition. And there's 4 significant interactions that are highlighted here. So as we already noted before, if a word is referentially unused, so this would be for like proper names, that has an increased likelihood of being rated as prominent. And this is especially so if in the presence of the auditory signal, so in the perceived prominence condition compared to the imagined prominence condition. On the other hand, words that are referentially bridging, so these are the words that are inferable from discourse context, these are less likely to be rated as prominent. And this is particularly even more so in the perceived prominence rating condition compared to the imagined prominence rating condition. And we find similar discrepancies when we look at lexical givenness as well. Okay, so the summary of our findings: overall, the likelihood that a word will be rated as prominent is similar in the perception and internalized production of prosodic prominence. And information structure influences prominent judgments similarly in both modalities. However, information structure effects on prominence are enhanced in the presence of auditory cues compared to ratings based only on the internalized production of prominence. The greater influence of information structure on prominence ratings made from auditorily perceived speech might reflect the convergence of acoustic cues and discourse context on the same prominence level for a particular word. Or an alternative explanation of this finding is that the discourse context may be rendered more salient in heard speech. Maybe it's more engaging and the participants are just paying more attention, and thereby boosting the weight of those contextual factors on prominence rating. So thank you, that's all.
All right, thank you, Jennifer. Again, any questions can be asked through the Q&A box or by raising your hand. Nina Hagen-Caldwell asks, can you say something about the relationship between linguistically naive judgments of prominence, so words that, quote, stand out, versus phonologically defined prominence, and how to best instruct participants to judge prominence?
Yeah, so I didn't report that here, but in other studies and most recently in my 2019 co-authored paper in Journal of Phonetics, we make toe-to-toe comparisons between the prominence ratings using rapid prosody transcription and prosodic labels in the Toby system for the same speech materials produced by sort of trained expert annotators. And there is a good relationship in the expected direction. So pitch accents that are sort of, you can rate pitch accents on a prominent scale according to their, both either according to the discourse context where they tend to get used or according to their acoustic manifestation. And either way, or in both, with both kind ranking under either criterion, we see a good correspondence with the relative prominence that comes from our rapid prosody transcription. So they're lawfully related in the expected manner. Let's see.
We've got a question from Jason Shaw. Do you expect acoustic measurements of prosodic prominence to explain the difference between perceived and imagined speech, for example, for the, quote, unused new words?
Yes, I think in these materials we did look at that. At the unused words, there were and a couple of other sort of interesting details when we drilled down. And I think that most of the effects we can relate to acoustic properties of the speech for the condition where the ratings were made in the presence of the auditory signal. This TED talk is a little bit interesting because the speaker, is very engaged and lively. And so is using a lot of different pitch accent types in all of the different information structure contexts. So there's not the expected relationship between the type of pitch accent and the type of information structure context is not really found in these data. However, there still is, the speaker still uses the acoustic expression to signal differences in information structure. So yeah, the acoustic measures I think are an important part of the story here.
All right, we've got a question from Yuka Tatsumi. Thank you for a very interesting presentation. The task reminded me of the prominence judgments training for L2 speaker. I myself, as an L2 speaker of English, have done a lot in English classes. By any chance, do you have any expectations of what kind of result you would get if subjects were bilinguals or L2 learners?
So I haven't used the rapid prosody transcription method with L2 speakers or for example, English learners in my lab, but I am aware of other people who've done that work, and it's pretty interesting because it shows that L2 speakers for English, these comparisons have been made for English with Japanese learners of English in particular. They behave very similarly to native speakers of English when they're rating the location of prosodic boundaries. But as you might expect, they don't behave like L1 English speakers when they're rating prominence. And that's where we see the biggest difference. In one study, I also compared Indian English speakers rating American English with American English speakers rating American English. And there also we found very similar responses for locating prosodic phrase boundaries, but very divergent responses for prominence. So I think language background makes a really big difference for prominence perception, especially. But interestingly, prosodic boundaries seem much more stable, much more strongly cued, both in relation to the syntactic structure and in relation to the acoustic cues.
We have a question from Laura Catherine Smith in the chat. Thank you for such an interesting paper. I was wondering if you had considered eye tracking evidence as a follow-up to see if the subjects might have easier processing for some types of words or differences or similarities between the words you were comparing for information structure.
I have not done an eye tracking study that relates to rapid prosody transcription. And I don't immediately have a plan to do it. It strikes me as being perhaps a little bit difficult because, you know, I mean, I guess it would be like reading, you'd be looking at their fixation on individual words as they go through. Yeah, it's an interesting idea. Thank you for the suggestion, Laura. I haven't done it, but it's an interesting idea.
Any other questions?
It's late, huh?
Yeah, I was about to say, so it is very late on the East Coast and much later, I know, in Europe, if anybody stayed up this late. So I think we'll go ahead and thank all of our speakers for this session, for interesting and stimulating talks, and go have dinner or go to sleep or do whatever you're going to do for the rest of your evening.
Sungen, are you still there?
Yes.
Oh, you know, I really liked your talk and I had a question like ready to go, and then Jason asked.
Oh.
And then you answered it really nicely too. And I felt badly because I didn't have anything to ask you because I was so focused on my one question, and then boom.
Okay. I think I saw your hand, but
yeah, I had my hand up.
Oh, I didn't see him.
Oh, no. I mean, I was trying to figure out like, where do I ask my question? And so I just raised my hand. No, it was fine. But I loved your talk. I love that study. It's really wonderful. And I really wondered about whether you would find if you varied like the depth of the syntactic embedding or the distance, the length of the syntactic constituent preceding the boundary, or the length of the upcoming constituent. Well, no, I guess that would be for production, not for perception. But I was really thinking about all of those factors, and I'm very sympathetic to the idea that prosodic boundaries are maybe not categorical, or that maybe there is a nonlinearity, but that there's gradients maybe on either side of a category boundary, if there's a category boundary at all. So
Yeah.
I'm very sympathetic to that idea, and you had a beautiful way of testing it.
Okay, thank you. So Sam and I started out this question, like we wanted to start from like really bottom up, like so many people assume that there's a prosodic categories, like 2 levels in every language, whether it's like the name of the categories are different, but still like we at least assume 2 different categories. But like we're thinking, like, is there really phonetic evidence for that?
I mean, you might.
1 minute warning and the session's going to be closed, just to warn you.
Carlos Gussenhoven has a competing proposal that there's no level distinction.
I see. Okay.
Yeah.
And I think it's a good start for testing syntactic phonetic evidence. So
absolutely.
I have different, syntactic structure.
Absolutely.
Thank you so much.
Yeah. Rachel, it was good to see you.
Yeah, good to see you.
Bye.
Bye, everyone.
Bye.